I've built an affordable gaming PC which can play games excellently at 1440p. Behind me is the all-AMD gaming PC and it's featuring the brand new Ryzen 5 8600G, which in my opinion is a bit of a mixed CPU, but more on that in a bit. Before I get into the video though, I want to say a massive thank you to both eBuyer and Western Digital for helping supply some parts for this PC. This PC build wouldn't have been possible without them, so make sure you check them out in the description below. So with that being said, let's not waste any more time and get straight into the PC build, or how I did the PC build, because it's behind me. So yeah, let's get to it. Starting off with the brains of this PC, and this is the Ryzen 5 8600G. It's a recent release from AMD alongside their G series APUs, which are featured on the AM5 platform. But the 8600G features 6 cores and 12 threads and excellent Radeon 760M graphics. And these integrated graphics should be able to play a lot of games at 1080p relatively well. So make sure you stay tuned because I will be making a video on it. I do have some issues with this processor, like its PCIe 8X interface for graphics cards, and it does have less cache than the Ryzen 5 7600, but I think the latter is the least offending thing about this processor. But despite this, I still think it's a decent CPU, but I do mainly recommend it for a small form factor PC where power consumption is a big concern. But if you're getting a discrete GPU from the get-go, like the 6700 XT that I'm using today, I highly recommend the Ryzen 5 7600 or 7600X. An AM5 CPU needs a decent AM5 motherboard, so I settled with the Gigabyte B650M Gaming X AX motherboard. It's a micro ATX motherboard. Yeah, the M means micro ATX, by the way. It has a fairly beefy VRM setup, and to be honest, I would probably be happy using a 7800X3D on a board like this, especially as Ryzen CPUs are quite efficient. The rear I/O is looking very strong with a 2.5 gigabit LAN, Wi-Fi 6E, which is missing on my iPhone 14 Pro Max, so cheers Apple, and USB-C 10 gigabits on the rear port, which is very good if you're a video creator like me, or if you just transfer a lot of files a lot of the time. All of this for £160 here in the UK means this motherboard is a solid deal. I am so glad that budget motherboards are back and they don't suck anymore. It reminds me of the times where B450 was just an absolutely solid offering, and it's great to see that motherboards are now affordable and they're great as well. To populate the B650M Gaming X's M.2 slot, Western Digital sent out their 2TB SN770M NVMe SSD. It's an excellent Gen 4 drive with TLC NAND, with read speeds of just over 5 GB per second and write speeds of just under that. It does have an SLC cache, which isn't the most ideal method for caching data. However, for a game drive, it should be totally fine. And it is, because I've been daily driving it in my main PC before this build, and loading times were nice and snappy, and I had no issues with this SSD at all. Its 2230 size means it is perfect for devices like the Steam Deck and Asus ROG Ally. But if you're building a desktop gaming PC, I highly recommend getting the non-M model. It shares the exact same specs, but it comes in a 2280 size, so it will fit in a PC like this with no issues, as I did have to use a little adapter card thing to get it to fit properly. Make sure you check it out in the description below. As for the rest of the build, the graphics card I went for is the AMD Radeon RX 6700 XT. It's a solid deal right now, and I'd much rather have this than the RTX 4060 and 4060 Ti. It has more VRAM, more memory bandwidth than both of these graphics cards, and in the case of the RTX 4060, it also has more rasterization power as well. And in the case of the 4060 Ti, it's cheaper and it has more memory. It will play games just fine at 1080p and 1440p, and even at 1440p if you enable a bit of FSR on quality as we've seen from a previous video, which you can watch up here or up there, it does perform quite well, especially with frame gen, as I've tried that in Starfield and it works really well. RAM was a bit of a weird one today because originally I was going to use 32GB of Patriot Viper DDR5 memory, but it didn't work with 2 sticks for some reason, mainly because it's probably not on the QVL for this motherboard. However, I settled with 64GB of Crucial Pro DDR5 memory instead, which works totally fine. The power supply that I've chose is the Corsair CX650. This is a solid, dependable, no frills power supply. It has 80+ bronze, which means it's somewhat efficient, and this power supply shouldn't blow up in a PC like this, so that's great. Little bit of a discussion time. I want to go over the issues with this PC because it was just so stressful to actually even to get it to boot properly for the first time. Essentially, first time I tried to boot it, it just wouldn't start at all. Like, it would power on just fine, like there was no issues with the power delivery or anything like that. But the issue was a BIOS incompatibility. It turns out when I tried to do the Q-Flash Plus, I might have used the wrong revision of this motherboard, because Gigabyte do kind of like soft launches with their motherboards where there are different revisions, and this is one thing that does kind of irritate me about Gigabyte, is the revisions on their motherboards. However, I used the Ryzen 5 7600, which I will be making some content on very soon, and it booted totally fine first time, but with 1 stick of the Patriot Viper memory. And that brings me on to my next issue which I faced with this. The Patriot Viper memory just didn't really want to work for some reason. It's not on the motherboard's QVL list, which kind of makes sense as to why I was facing issues with it. So I thought I would put the Crucial DIMMs that I had into this motherboard, and lo and behold, it worked totally fine with 2 sticks of memory in dual channel, even with AMD Expo enabled. So yeah, that was one of the strangest issues I ever had to face with a motherboard. And it's not like the Patriot Viper DIMMs are not working either, because I'm literally working in my main PC right now. But if you want to see how I fully diagnosed and fixed this issue with this PC, that will be in a video listed up there or up there. I can never remember where YouTube puts it. But other than that, I mean, the PC is working and I've benchmarked it as well, and it's running totally fine. So yeah, just a little bit of a setback, I suppose. Starting off the benchmarks today with Cyberpunk 2077, and at 1080p the performance was very good, getting just north of 81 FPS on average, with that 1% low staying just above 60 frames per second, which is excellent performance on the Ultra preset. 1440p does see the average and 1% lows drop quite significantly, but this is a trend that I've seen with Cyberpunk in the past with multiple different GPUs. So if you were to tweak a few settings around, I think you'd be totally fine gaming on Cyberpunk with a similarly spec'd PC. Jedi Survivor is up next, and I've had this one for quite a while, but this is my first time benchmarking it, and it does seem the 1% lows and the frame times, at least on this PC, aren't particularly that great. However, the average frame rate on the high preset at 1080p is getting north of 70 frames per second, which is great, but the 1% low is lagging behind by almost 30 FPS, which is not so great. Switching up to 1440p sees that 1% low close up to the average, which is always something nice to see, but the average frame rate is below 60 FPS, so depending on what you're wanting out of a PC, that may not be that ideal. So I would recommend tweaking a few settings. Fortnite, as always, will perform decently on a PC like this at both 1080p and 1440p, and you're good enough for a 144Hz experience at both resolutions. So I wouldn't really worry about Fortnite's performance at all, and if you were after more frames at both 1440p and 1080p, I'd recommend using the Performance API instead of the DX12 API, which I used today. Testing this PC on Hogwarts Legacy has kind of made me realise how easy it is to run, because on the high preset, getting north of 100 FPS on average at 1080p is an excellent feat from this PC. The 1% low was not in the best of places, but it was smooth enough in my gameplay, and that's kind of what matters. 1440p still sees excellent performance, getting above 60 FPS still, and that 1% low does close up to the average. So gaming at 1440p is probably the sweet spot in Hogwarts Legacy on a PC like this. Forza Horizon 5 tends to perform better on AMD cards, and to be honest, that basically stays true today. Getting north of 130 frames per second on average at 1080p, and that 1% low stays relatively close to it, getting 108 FPS there. So there's no issues at 1080p, and there's also no issues at 1440p, getting just south of 100 frames per second, and the 1% low was also looking great at 79 FPS. So the Ultra preset is the one I'd recommend, and probably just leave this with TAA anti-aliasing, because the game looks absolutely incredible, particularly at 1440p. Counter-Strike 2 is up next, and as always, this game does seem to suffer with the 1% lows, as it did at both 1080p and 1440p today. But good news, at both resolutions, you're good enough for a 240Hz experience, as it does seem we are quite CPU bound at 1080p, as the average frame rate only dropped by 10 FPS down to 265 at 1440p. So I would probably recommend 1440p for Counter-Strike 2, as you're virtually getting the same performance, but either resolutions are playable. F123 is up last, and on the high preset, the game looks amazing and performance is incredible across both resolutions. Both 1080p and, to a lesser extent, 1440p are good enough for a 144Hz gaming experience. Alternatively, if you're playing at 1440p, you could just lower a few settings and get above 144 FPS on average, if that is something you're after in a game like this. But either way, performance across both resolutions in F123 is totally, well, I'd say it's great. So this is the final product. The all-AMD gaming PC is fully complete, and it's been running some games, and now it works with no booting issues, so thank you to that. I'm just sitting here admiring it, to be honest, because I think it looks quite good. I'm really liking the stealthy look I went for in this PC build, and to be honest, it wasn't intentional, but I think the Noctua NHU12S does really help with that stealthy vibe. Pairing it with the B650M Gaming X AX from Gigabyte as well, and I think you're on to a winner if you want a stealthy sort of minimal RGB build. There's a thing with RGB that I don't like, and that's when you just leave it on like the rainbow and all the flashy stuff. It just looks kind of tasteless in my opinion. But if you put it onto like red or orange or whatever your favourite colour is, I think it's a lot more tasteful when you use RGB. So essentially what I'm trying to say is, if you use RGB effectively, it looks quite good. But can you tell that I haven't scripted this part of the video, because I'm absolutely waffling right now? And that moves me on to my next point. There are a few things I would like to change about this PC, starting off with the processor. The Ryzen 5 8600G isn't really a fit candidate for my testing PC, as that's what this is going to be, thanks to its PCIe Gen 4 8X interface for graphics cards. That's just a really weird decision from AMD, and it's not one I can get behind, because it's just, yeah, I don't know why they'd do that, even when the 5600G had a PCIe 3.0 16x interface, so it just doesn't really make that much sense to me, especially as I'm going to be testing graphics cards in this system. So that's why I'm going to be putting a Ryzen 5 7600 in here, and that has a full PCIe 5.0 16x interface for the graphics card, and it also has more cache as well, which is very helpful for gaming. Also, I want to put a much more beefy power supply in here, as I want to be testing more power hungry graphics cards, and the 650 watts is totally fine for a build like this, but I do want more wattage headroom if I want to test something like an RTX 3080 or something like that, because that just absolutely gobbles power. And the last big thing I want to change is the memory. 64 gigabytes of DDR5 memory in a gaming PC is just super overkill, and you won't see any benefits from it in a gaming workload. And I'd much rather have it back in my editing workstation, as I would actually benefit from the extra memory there. I will be trying to source 32 gigabytes of 6000 megahertz DDR5 memory for this PC build, which will basically be in a version 2 or a part 2 to this build, where it will be fully running at its best. So yeah, overall this PC build was very stressful, but I got there in the end. And there's quite a few things I would like to change, but for the most part, this PC runs games quite well at the minute, and I'm pretty happy with that, truth be known. I will be putting the Ryzen 5 7600 back in here very soon, as I've got a lot of GPU testing to do in the next couple of weeks, as I've got 3 graphics cards showing up, hopefully sometime soon. So yeah, we're going to want that 16x interface for that. But I want to say a big thank you to both eBuyer and Western Digital for helping make this PC build possible by supplying some of the parts that I used today. Make sure you check them out in the description below. For some reason the CPU fan just kicked in quite a bit then. I don't know what was going on then. But you can see how I troubleshoot this PC up here, and you can watch how the 6700 XT gets on in another video down there. And I'll catch you in the next one.